Right, so these are the topics we are going to cover in today's lecture. A little bit more about data warehousing, and then the process that we follow in data warehousing. We call ETL process. So what do you mean by this ETL? And then I'll go through the concept of big data. Now that is one of the hot topics in current environment. What do you mean by the big data? Why we need big data, etc., etc. We learn very briefly about that concept. Okay, so you will learn all these stuff in higher education, but I like to give you kind of a small preliminary introduction, right? Right. So before we move into anything else, let's think about this concept, because when you go to industry, probably you will think, okay, why we don't use composite keys? You remember that when we draw entity relationship diagrams in this semester, we tend to use composite keys, most probably in the weak entities, right? So we may have 2, 3, or 4, even 5 columns as composite identifiers in certain weak entities. So the main benefit why we introduce these composite keys, because then we can easily enforce the business rules in our diagrams, and we can actually communicate these rules very easily with unnecessary stakeholders, because it will give a kind of a real world feeling when you communicate it to the other stakeholders, so they can easily navigate through the diagram and see whether the rules are properly implemented in our databases. So that is the main benefit. But the main downside of composite keys, we may have, when we implement it, we may end up with very long, clumsy primary keys, and then probably if you implement it as a primary keys, if you borrow something from the other entities, definitely may have very long foreign keys as well. So that is the main drawback, because the implementation stage, it's a bit of a work to do, right? Because the keys are very large. So in practice, we seldomly use these composite keys. So what we do in practice, we usually replace these composite keys with some surrogate keys, right? So surrogate keys are some kind of introduced key, or maybe generated by a database management system, a sequential key from a list, right? So auto-generated number. Even if you use Microsoft Access, they have a function called auto, right? So you can use the auto now as to generate surrogate keys instead of composite keys. So the main benefit of surrogate keys are they very simple to use, faster because searching, because it's a sequential number, and also it requires less storage space compared to a long, clumsy composite keys. But main downside or disadvantage of having surrogate keys is we are not able to actually enforce the business rules and then show constraints in our databases, right? Because these keys are very much, there is no meaning attached to any of these sequential numbers, right? So database programmers, or even sometimes the application programmers from the front end, they may require to write additional codes to enforce the business rules. Since we don't use composite keys, we need additional codes in place to make sure that constraints are not going to breach by any transaction. So that is the main reason So these are drawbacks as well. Because sometimes some companies I work prefer composite keys than surrogate keys. It depends on which organization you are working on and then the IT environment. Yeah, so we haven't used that in this unit, but after INF10004 unit, when you go to uh, higher education, probably you will use surrogate keys, basically. Okay. Right. So let's come back to what we have talked last week regarding data warehouses. Now remember last week I had a kind of a discussion the differentiation between the databases or transaction processing databases and data warehouses, right? So basically, why we need data warehouse? Because some queries, for example, our data, probably the data management people who like business analysts or mid-level managers or higher level managers, they probably need to analyze millions or billions of rows sometimes to make decisions, to make some reports. So it's actually a good idea to have a separate database for that purpose, because databases that we build for transaction processing systems are not appropriate for these kind of aggregate queries, because if you run these stuff on top of the normal transaction processing processes, what will happen? It will actually constrain, it will put additional constraints in our database servers, and then it will actually impact the query performance as well. So the queries will run very slowly, and then it will greatly impact our transactions in transaction processing systems. The reason is because the schema we have developed in transaction processing systems are normalized, right? Because we have a lot of checkings, constraints in case, check constraints, etc., etc. And there can be lots of joins between different entities, right? So we have more granular level or low level data in place in transaction processing systems, and we have designed the system for that purpose, right? So if you run aggregate queries on top of these structures, what will happen is it actually slows down the query performance of your business analyst query performance, basically. So the solution needs to create a separate database. We call them as the data warehouses. So when you create the data warehouses, we need to remove unnecessary low level of data, because some columns, some rows, probably we don't need those things, right? Or otherwise we can actually aggregate some of the columns together, because we don't need that kind of granularity in our data warehouses. So we can remove these unnecessary low level of data. So that means we can have a very few tables in our data warehouses rather than having more tables compared to transaction processing systems. But the main thing about data warehouses is we should allow actually redundancies, because if you have more redundant data, that means we can easily run aggregate queries more easily than having more tables, right? So redundancies are okay, because it actually advantage in data warehouses, because it will increase performance of the queries. Right. So the other main reason why we need a data warehouse platform that is because the organizations have different types of heterogeneous types of database systems, because The reason is different vendors will supply different types of databases, because we can't rely on the same vendor to supply each and every database or each and every application for a company. Okay. So these databases supplied by different vendors will not going to talk to each other, because they are not designed to have compatible with each other, and that means it's not easily exchange data between these databases, right? Um, Another main challenge that people, IT people are actually facing in these sort of databases is there are different meanings attached to different columns in different databases, or even the data columns in different formats or data format, right? So it's quite different, right? Okay. And then different names can be. So there are a lot of challenges in place if we have many types of databases in our organization. So that is another. So that is why we have data warehouses. So if you have heterogeneous databases in our organization, so what we need to do is we need to go through a kind of process to extract necessary information for data warehouses, and how we could sometimes we need to clean some of the data, and sometimes we need to reject some existing data because we don't need that kind of data, right? So we have kind of a process that we need to go through in order to create the data warehouses. So that process we usually called as ETL process. So E stand for extract, T stand for transform, and L stand for load. So we need to first extract the data from different systems, or source. We call it as source systems. So we need to actually determine which tables we need to take, and which columns in the tables we need to take, etc., etc. So this is it has kind of a steps that we need to follow. So that process is called extract process. And then we need to, once we determine and extract the data, we need to transform these data to data warehouse environment, because sometimes we need to clear data, sometimes we need to reject some data, and then what we can do is we can then load these data into a suitable form to the data warehouse. So that is done by scripts. So we can run scripts. We can actually write SQL scripts to handle these processes. So it's a kind of a time-consuming thing to do. So what are the main issues related to this ETL process? One of the main issues, one of the major actually issues that I have actually come across is getting these data into the right place is a kind of a cumbersome process. As I mentioned before, it can be, the data can be, relevant data can be stored in many varieties of transaction processing databases. And also the thing is, most of those systems are not owned by the same organization. Sometimes the subsidiary of our organization can be owned by one system, or maybe a partner organization can be owned by one system. So it's actually not a kind of an easy task to plug the data we require from these source system, because we need to be the authority, and also we need to comply with some standards as well. So sometimes I came across some challenges as well, because some companies, even your sister company in the same organization, have kind of, they don't want to disclose some of their information, because the information or data in any company, they usually, it gives some kind of a political power, right? So they don't want to disclose this kind of stuff. So that is another challenge actually. And then the other important challenge I have noticed is mostly systems are not actually built to easily export into a different format. So it's another challenge to get these kind of data. So we need to go through again, and then then we need to follow some processes to do that if that not suits. So it takes time as well. So that is one of the main difficulties, getting these data into these into the data warehouses. And then the other difficulties are actually we need to actually clean these data. Even we able to get this data or access these data, how are we going to clean it? How are we going to transform this data into a compatible format into the data warehouse? Because in some transaction processing systems, their quality of data is very poor because they design for some specific purposes. For example, some systems may have a postcodes. For example, in a customer table, there or the transaction tables, the postcodes are not necessary. They can have lots of not nulls in the postcode columns. But think about the data warehouse. When the decision makers wanted to make decision based on the different customers, based on their different suburbs they are coming from, the missing postcodes could seriously impact the functionality or the decision quality of the data warehouses as well. So before we transform these data into data warehouse, we need to make a decision: do we get rid of missing values? What we need to do that? So these kind of decisions has to be made. And also sometimes data, the column names and different data formats probably a challenge as well. For example, some columns can be named in some tables as a student number or STD number or SID, etc., etc. We need to actually transform all of these into a common category before we load these data. So sometimes these columns can have different meanings, because that is the other important thing, because SID, student ID is meaning maybe two different meanings in two different tables sometimes. So we need to actually clarify that as well before we transform or before we move these data into our data warehouses. So data has to be transformed, or data these need to be cleaned, or sometimes we need to reject the data before we upload it to the data warehouses. So usually we do this as automated process. So we try to write some programming scripts to handle these. We feed up some rules into these scripts, and based on these rules, the ETL process will take place. So sometimes what happens is if you face kind of very serious issues in the data quality, sometimes we need to go to the source systems, and then we need to advise the appropriate database handlers or database professionals in that particular company to correct the source system, because it will seriously impact the data warehouse queries later on. So that is another thing that we need to think about. Right, so when you create data warehouses, looks like, I mean, they have different types of tables compared to transaction processing system tables. We have done a lot of our designs. This course has been designed to handle the transaction processing system. So far, we have created these entity relationship diagrams to represent some sort of a transaction processing system, right? But when it comes to the database, data warehouses, their schema is completely different, right? So their ERDs can be completely different. So usually in data warehouses, we can have two types of tables. So we have one type of table called dimension table, the other type of table called the fact table or the measurement table, right? So basically, dimension tables looks like a strong entities in the transaction processing system, but in data warehouse, these dimension tables are often denormalized. So that means we have lots of redundant data in the dimension table. So that's perfectly okay. because we design this to easily query the large amount of data in a given short period of time. And then we have another type of tables called fact tables or the measurement tables. So basically, they looks like more weak entities, right? Remember the weak entities. We when we design the weak entities, we tend to record the important facts regarding the particular business process in the weak entity, right? For example, if you have say orders, and then we have order line items in the weak entity, right? So order and order line items, a weak entity. So these are the order line item entities where we actually record all the quantities and all the facts or the measures regarding a particular order, right? So it contains all these quantified measurement kind of measure. So these weak entities. So likewise, in the fact table actually contains all these quantified measures in our business, in our tables that represented in transaction processes, etc. So order line is a classic example, and then, for example, another example may be the sales table. It contains the sales categories, maybe sales quantities, sales price for each unit, etc., etc. The enrollment details of the students, right? It also contains all these facts for the quantitative information. And then also, for example, we learn, the database that we have regularly used in this semester. We have actors, and then the films, and then movies, and then we have in the middle casting, right? So the casting table also contains more facts, right? More measures, who casted in which movies, etc., etc. So these are called the fact. So fact table looks like more weak entity. Dimension table looks like more a strong entity in the data warehouse. Now the schema or the structure of the data warehouse is quite different. So usually fact tables and the dimension table can be displayed in a ER diagram or something like this, right? So it's like a kind of a star kind of ER diagram, right? So we call it as a star schema in data warehouse because we have one fact table, but we can have different dimensions surrounded by it, right? So we can have one table, product table. It has all the product related information. And then we can have the customer table. We can have all the customer related information. And these products are bought by certain customers. So these are the values, right? So the sales table contains the values, the quantities of the products that each customer bought. And then we have actual dimension. So usually in the data warehouse, we have a separate table we create for the date. Because the date can be sliced into different categories, right? We can have months, we can have week, we can have hour, seconds, etc. We can actually slice it into smaller unit. Because the main reason is in case is we find out which customer bought which product at which date, which time, etc., etc. So like going through these different dimensions, we can actually create some queries to handle these facts, right? To aggregate queries to handle these facts. So that is the basically the ERP or the looks like in the data warehouse. So basically, dimension tables here contain the descriptive attributes, as I mentioned before. All these descriptive attributes usually you can find it in the strong entities. For example, customers, products, students, and region they are coming from, etc., etc. Dimension table. So dimension table Sometimes we actually call it as lookup table. So we can actually use these dimension different lookups to slice the facts different ways, right? So that is the main idea. So these examples you to dimension tables, you can see the customer. So sometimes these columns in customer table in the data warehouse probably coming from maybe 2 or 3 or maybe 4 or 5 other strong entities. What we have done here, we put that everything into a one big strong entity called the customer. So likewise, there is another strong entity called the product. Product entity also can contain several columns which come from different strong entities in your transaction processing systems. And then we have the fact table. As I mentioned before, they contain more transactional or weak entity kind of data. So events, activities, purchases, results, etc., all these stuff are contained in the fact table. Now remember, the fact table also has several columns. Now remember, the more important thing is this fact table actually have foreign keys. Actually, these foreign keys are pointing towards these dimension table. So in this case, we have customer ID, which is pointing to the customer table, and then we have the product ID, which is pointing to the product table, and then we have the sales date, sales date probably pointing to the date table, right? And then the quantity and selling price for the quantity are the real facts in this particular context. So maybe the quantity is the real fact, selling price may be coming from the product table as well, or maybe some other table. Right. So usually dimension tables are in the second normal form. So it can have many non-key dependencies. That is perfectly okay, because redundancies will faster the aggregate queries. So that is the main reason. So you can see here in this case, the customer table, we have few redundant information highlighted in blue color. Okay. So data warehouses redundancies are okay. So this is a customer table. The customer related information. So we have a lot of redundancies as well. So it's a kind of integration of bunch of other tables as well, because region name coming from the region table, maybe we have customer IDs, customer name coming from customer, real customer table, but we put everything together to make it as a big customer table in this case. So the main advantage of having the lesser number of tables is because then we don't need to have lots of joins in order to run aggregate queries, because when you have more joins, that means it slows the query processing time. So the cost, if you think about cost and cost benefit analysis of these redundant data storage, is quite okay, because cost of storing of redundant data is quite actually less in this today's world because of the improvement in the technologies. And then the main advantage of redundancy is we have now fewer joins. Then we can have faster queries. So that is the main reason. Yeah. So this is the dimension model, as I mentioned before. So every row in the fact table in the sales table actually refers to one of these dimensions, as I mentioned before, that highlighted in this particular schema. So in a normal transaction processing system, we may have designed our entity relationship diagram something like this. Now, this is a typical example. It says, so if you go through this entity relationship diagram, you can see the parents are related with the families, and then each family have the students. Students are enrolled in the subjects. Subjects have different syllabus, and then different teachers are teaching these different subjects. And then once they enroll, it looks like we need to record the marks, right? If you think about that, you can see the dimensions in this case. We have parents and family, subjects, teachers, right? All these are the dimensions. So what are the facts? Facts probably may be the marks, right? Facts will be the quantified information in this particular model, right? So if I create a data warehouse schema or star schema in this case, so my sub schema looks like this. We have few number of dimension tables. We have students. Actually, you can have student. So in the student table, I can have everything in this case, right? Family information, parent information, student information. Everything can be put in the student table, and then we have the subject table. So I can have all these information like teacher details, subject details, syllabus details, everything can be in the subject table, and then we have the date table. So this actually contains the dates, and the mark is here. So we can actually now query how many students got 50% in this semester compared to the last semester for this subject, etc., etc. So we can actually go through these 3 tables or 4 tables and calculate what we require. So it's easy. Now we have only to access 4 tables compared to this, right? That is about data warehouses. The important topic I like to actually discuss with you is the big data, right? So the big data is now becoming a hot topic. Actually, there were 3 eras in the past. Each era has been focused on different perspective of the business transaction or business data, or the different types of data. For example, the earliest era, the organizations are actually focused on business related details, information, right? So they actually try to have create more transaction related systems to capture more accurate transactional related information or the data. But then again, second era comes where the business intelligence played a much more crucial role in deciding competitive advantage organizations. So in that particular era, businesses are more focused on more intelligence generation. So they have tried to create more what we call these so-called data warehouses to generate this business intelligence. But now we are now in this third era. It's a big data era because we have seen different technologies come into play in recent years, right? So if you think about past few years, 10 to 15 years, where lots of devices has been come into play, and then the internet become one of the main sources to generate new kinds of data. So data storage devices and then the new technologies are coming into play in the database era, right, or in the database domain. So all these data storages and new retrieval technologies together with internet are commonly referred to as big data technologies, right? So the need for this kind of new technologies has emerged probably due to the changes where the data has been created and the type of data that are being generated right? And the speed at which these data has been generated. For example, in recent years, you may have noticed a term called Internet of Things, right? IoT, often used to describe a variety of data or variety of actually devices. For example, we can have personal devices like smartphones, smart watches, fitness bands, etc., etc., and also some commercial devices like engines or smart cars and smart trains that are increasingly connected to the internet, and then they actually generate, and it has a little bit of intelligence as well in these devices, and it has a computing power, right? So these billions of devices around the world are collectively probably generate very large volumes of data that is of interest to various kind of companies or various stakeholders. And these various devices also generate data very frequently, and there was a case for organization to think about differently how we going to process all these kind of um, information, right? Uh, so the traditional data management technologies that we created to capture the more business related processing, business related information initially will not going to work in this third era, right? So we need a little bit furthermore capabilities in organization in order to, especially in the analytics, right, to analyze all these billions or trillions of data generated. How are you going to make it more intelligent for the organization to make decisions? So that is where the big data come into play. So so in the big data, we can say that there are kind of five characteristics. We call it as 5 V's in the big data. Obviously, the volume is one of the key things, because nowadays organizations tend to, tend to capture and then to actually record more and more data. So nowadays, actually, we are talking about data storage in exabyte terms, right? Not even gigabyte, right? So we have gigabytes, terabytes, exabytes, right? So all these devices generate billions, millions of exabytes of data that we need to actually store and retrieve later. That is what we mean by the volume. And then we have the variety as well, because variety refers the exposition of data and different types of data generated by different sources, right? For example, we can have data generated by our wearables, or maybe social media, right? And tweets, so different tweets generate some data some companies are interested in. So the variety is there, right? Like, unlike in the transaction, basically in a normal transaction, we know exactly what kind of transaction, what kind of information we on. But now we have variety, right, in place, because we don't know exactly from where the data is generated. So whatever it comes into play, we need to capture, we need to record. That is what we mean by the variety. Because sometimes we can have sensors, right? So sensors generate data. Server logs in company server logs actually generate a lots of data, which is interested in analysis as well to generate some decisions. Sometimes the emails or the texts that we exchange between different organizational units probably generate some interesting data that organizations are interested on to make decisions. Social media, different geographic location, different machines, and so on and so forth. All these actually are, and also videos and audios that we record on YouTube and exchange via the social media platform actually generate some sort of data that organizations record interested in. That is what we do there. Right, and then we have the velocity. It's kind of a speed of the data this arrives for companies. So big data analytics usually need to consider all these speeds of different sources of data generated, because different streams generate different type of data and different speeds. So we can, for example, we can have sensors generate a large number of mobile, say for example, sensors in the mobile device generate a large number of data that can be interest to some companies, right? For example, Google. You always, when you use Google Maps, it generates millions of hotspots or places you visit. So how important is information for the Google to analyze, right? And then to suggest some sort of new information to you. So the variety velocity refers to the speed of these kind of data which arrives into the companies. And then we have the variety. It's a dimension of the data that about desired characteristics as well as different type of ways that we have to deal with. So because of the richness of data types and sources of data, different sources of data, that these traditional databases that we use probably are not going to able to handle all these varieties. For example, we are not able to handle the video or the audio type of data, right? So how are we going to handle all of these stuff? So that is another thing that we need to make sure. And then we have the value, right? Because what we need to actually remember is whenever we capture the data and analyze the data, we need to make sure that it will provide some sort of a value or meaningful value for the organization, because not all these data is not not necessarily important for the organization to maintain. So the technologies we develop and technologies we use has to have kind of capabilities to generate a meaningful insight to make to decision makers. So that is what we mean by data. There is what we mean by the value. And the other important thing that we need to remember is all these data that we generate, weight type of data we generate coming from different sources, right? Internal sources, it can come from the external sources. They actually they call it normally we call it as data lakes, right? So it's a, we can call it as a kind of large integrated repository for internal and external data. So which doesn't have kind of a more predefined schema, isn't it? Because when you generate different data from the sensors in the mobile, from videos from the YouTube, or tweets from our Twitter accounts, or some kind of chats in the social media platform, we can't have kind of a structure, right? So what we do is we collect everything. So data lakes usually include this capability. So we can put all these raw data for a long period of time, and also the results of processing all these data can be put into the database. And also we can actually have capabilities in these data lakes to harvest some sort of important intelligence from these data lakes, right? And most importantly, these data lakes has to be more flexible enough. So Actually, what we have we have kind of when you design a data, I mean big data technologies, the schema has to be schema on read rather than schema on write. So schema on write means um, uh, we create a pre-existing data model. For example, when you design your ERDs or when you create the table, we first design the ERDs. We define the structure. How are we going to handle the particular context in our database? So we know exactly this is the context, this is the model we're going to implement in the database. So all the transactions, business transaction confined into that model, right? So that is how the traditional databases are designed, or relational databases are designed. So we call it a schema on write, okay? But the big data, as I mentioned, because of that five V's, 5V characteristics, we can't have a kind of predefined structure, right? We call it as schema on read, right? So data models we determine later. It depends on how we're going to use it, what kind of context you are using it. So we can have
Sorry, guys. I think it has been something has happened. So I just go through on live now. So there are two types of ways that we can design the schemas, right? So traditional databases, as I explained earlier, we define the schemas. We have predefined schema, right? So ERDs, we have predefined schemas. So in big data, because since the data is coming from different sources, different structures, different characteristics, so we can't do kind of predefine the database, how the database looks like. So what we can do is when we use the databases or when we use the data, of course, then we decide how the structure looks like, right? How the structure. So that is why we call it as schema on read, right? So it's a different technology. It's a different ball game. So there are various technologies we use to structure or the record the information. We can use actually XML or what do you call XML technology or JavaScript notation or JavaScript, what do you call JSON technology as well to structure the big data, kind of data. So we have data lakes, as I mentioned before. We can actually record the data, dump every data that coming to the company, and also the what producing the company in the big data lakes. Because nowadays the cloud, we have cloud technologies. The data, recording of the data is very easy. I mean, very less expensive or not much, money need to be spent. So the data lakes are basically one of the methods that we can actually use to record. So in this slide, actually, I explained the difference between the schema on a read and the schema on a write. So as I mentioned before, schema on write, basically, we need to gather the requirements and then structure how it looks like, what is the context we are looking at, then we model it, then we develop the schema, and then we enter the transactional data based on the schema. Okay, we have put a lot of constraint, extract, etc. That is what we have done in a standard normal structured databases, right? But it's completely different in the big data because there are various things. Data can be generated by tweets, data can be generated by social media, Facebooks, right? or maybe YouTube. People are exchanging, emails, right? Instagram, etc. There are so many ways where the companies are so interested in all these stuff, right? We can't predefine the structure in a logical way. So the main idea is to collect the data, right? Collect the data, and record the data in different technologies. We can use the JSON technology, or hypertext markup language, or XML technology to record the information. And we store the information in the cloud data lakes, and then we define the how it looks like, the structure looks like when we try to use the data. So I have given in this slide actually examples of a JavaScript object notation, how we going to structure a piece of data using JSON or JavaScript object notation, and XML, or we call extensible markup language. Now, if you know a little bit of HTML stuff, you may have used XML language, because we don't have to. So this is a kind of one way to record, right? Now this is actually an example of how we record a one product, right? Or product related information using XML and JSON notation. You can see in the product we have a product number, and the product name, product price, etc., etc. So we may have three records here, right, in XML, and this is how we show it in the JSON or JavaScript notation. So this is how we record the data in big data, using big data technology. Right now, this is just to give you a small not the example, just to give you a small, if you use business in, data warehouses. And now I'm just going through the other direction again, a traditional, more structured oriented data warehouses. Sometimes we can use some intelligence tools to generate some business intelligence. If I don't know whether you may have heard about these tools. We have lots of other applications like Cognos, JDocs, Power Pivot, Tableau kind of areas, applications. It's very user friendly. Sometimes we don't need to actually use lots of SQL queries to write these stuff. These applications basically drag and drop kind of things you need to do, right? So if you do a kind of there is a unit in higher education one. If you're very interested in business focus IT kind of or database kind of areas, probably you can specialize. You can do actually INF10004 business intelligence subject. So it's actually that subject is going to give you some kind of an idea how we use these sort of technologies, or basically business intelligence tools, to generate some sort of kind of business intelligence, right? So we can do some kind of mining the data. We can extract some intelligence from the existing information, or maybe we can visualize how the historical patterns work. Then we can actually predict how the future looks like from the historical data. So there are a lot of analytical kind of capabilities available in these business intelligence tools, where we can use to generate so many kind of things. So yeah. And also there's another, even if you are, I don't know whether you have heard, the Excel itself, we have a capability called Power Pivot. It's add-on capability in Excel that that we can use to suck information from the data. Now, if you have used the Excel, there is a kind of Excel Power BI capability where we can actually link the Excel spreadsheet to existing databases like Oracle, and then suck information from different tables in the database, and then drag and drop some columns and generate these kind of reports for the management. This is another important one of the key areas for the business related students who are like to specialize in. So these kind of areas you don't need to actually learn a lot of SQL queries, because it's kind of just dragging dropping sort of information. It's really not that important for SQL kind of stuff. But if you're interested in kind of big data sort of areas, there are so many units in higher education, especially in computer science area, and even in, I think, business area also. But you need to have a little bit of a mathematical or statistical knowledge here, because we are in that these sort of languages or the areas, you need to actually slicing and dicing the things based on some sort of a some sort of formula. So you need to build the formulas to make sure that you grab the required information to generate some reports. Yeah, so there are so many other units available in higher education. Business intelligence is a one unit, right? So they are teaching all these tools like Power BI, JDocs, Tableau, etc., etc. And then if you're actually very keen on learning more SQL programming kind of database kind of areas, probably the way you can specialize in the higher education is doing database systems, right? So in there you will learn how to construct data warehouses, how to run the databases in a multi-use environment, right? How are you going to back up the databases, right? How are you going to recover databases, etc., etc. So all these stuff, so most of all these preliminary complicated areas, you will preliminary stuff will be taught in the database systems. But there are some other range of database option, units available. Database implementation, it's a kind of a project-based unit. So basically here in the database implementation, you build a database from the scratch with graphical user interfaces. Sometimes you can build the databases. So that unit actually teaching that. And then there are so advanced units like database administration and performance issues, plus database programming kind of units. Actually, they go more in depth into the databases, like especially in the database programming, they actually integrate all these object-oriented programming knowledge that you gain through your first and the second semester or second year studies to integrate into the database environment. Now that is like very programming very intense kind of unit, where you need to know lots of in-depth knowledge in in programming as well. Yeah, so these are the units. So we have range of units. So that means you have a choice. If you're looking at the databases, guys, is very developing. I mean, it's been never going to die, right? This is a very good opportunity for you, in future to specialize and put your career into this direction. There are plenty of opportunities available in the databases. Yeah, that is something that I like to actually highlight in today's lecture, guys. That's the end of the lecture 12, and basically that is the actually end of our semester lecture series in this semester as well, because we don't have any formal lectures in next week. So hope that you have enjoy this subject. May I know your feedback? I mean, I will really enjoy this database subject in this semester. How did you feel? How did you compare your knowledge in week 1 and your knowledge in week 12? If I ask that question, how are you going to answer that? Did I add some specific value to you, your knowledge in the data. I know it's very intense in some weeks. Just let me know little feedback. Are you really satisfied with this subject so far? Etc. etc. I really like to know your little feedback regarding my subject.